Hi everyone, so let's get started and let's clear all our doubts about transformation of functions. So please get familiar with the standard format of any function, what it looks like, and we will get familiar with all these terms. Okay, so it is a multiplied by function of k into bracket x minus d plus c. Now this c value means that the function is moving vertically either upwards or downwards. Okay, we will get into details in a minute. This a means that it denotes vertical stretch or compression. So basically this a and c value are related to y-axis. Okay, movement related to y-axis, and everything inside the bracket is all about x-axis. Okay, so this k, this d, they are all about x-axis. Now I want you to remember that a and c, they just behave the way we can just look at it, but this k and d are a little bit tedious. So you can remember that this k and d works opposite the way it looks like. Okay, so you will understand in a minute. Just give me a minute. So I just want you to go through this first. It says that y is equal to f of x plus c. So basically if my c value is a positive value, it means that my function is moving c units upwards. Okay, it denotes vertical translation of c units upwards. Similarly, if my c sign is a negative sign, it means that my function is moving c units downwards. So this c value denotes vertical translation. Again, a positive c value means the function is moving c units upwards. A negative c means that the function is moving c units downwards. Okay, another one says f of x plus d. Now mark that here this d is inside the bracket. It means it's denoting something about the x-axis, and whatever it looks like, it's behaving in the opposite manner. So it says plus d. It means that the function is moving horizontally. Why horizontally? Because it's all about x-axis. Inside the bracket everything is all about x-axis. So horizontal translation, now it is a plus d. So remember what I said, opposite of what it looks like. So horizontal translation of d units to the left. You can also look at this like x plus d is equal to 0. It means that x is equal to negative d. So this bracket is equal to 0, and you will see what it looks like. So x is equal to negative d. Now negative values are on the left hand side. So horizontal translation of d units to the left hand side. Again, inside the bracket, so talks about the x-axis, f of x minus d. Now here it is a negative d. It means that the function is moving horizontally d units to the right hand side. Okay, so that's about the vertical translation and horizontal translation. Now we will talk about vertical stretch and horizontal stretch. So a multiplied by f of x. Now remember a and c are related to the y-axis. So a means vertical stretch or vertical compression. Now here you need to remember that if a is greater than 0, or I believe greater than 1, sorry, greater than 1, and if a is less than 1, it means that, so when a is greater than 1, it means vertical stretch, and when a is less than 1, it means vertical compression. Now when this a moves inside, so this can technically be the value of k as well. Okay, the variables can change. So you can look at it as k as well. So remember what I said, everything inside the bracket about the x-axis, and it works opposite the way it looks. Okay, so k or a is inside the bracket. Now remember, when it was outside the bracket and a value was greater than 1, it meant vertical stretch. So now when a value is greater than 1, do the opposite, literal opposite of vertical stretch. Opposite of vertical is horizontal, opposite of stretch is shrink or compression. Okay, similarly when a is less than 1, it means horizontal stretch. Okay, another form I want you to remember is y is equal to negative f of x. So when the function becomes negative, it means that you are reflecting the whole parent graph over the x-axis. Okay, why so? Because when the function becomes negative, it means that the value of y becomes negative. Okay, so if the function is over the x positive and y positive, you have to reflect it in order to make the y values negative. Okay, and when the sign is inside the bracket, then it means that the reflection is over the y-axis. Okay, I'm going to attach and also put a screenshot of this, also put a picture of this so that you can take a screenshot of this. Okay, now we will look at each of them into detail. So the first one is vertical translation. Okay, now before we move ahead, I want you to recall the parent, what the parent function's graph looks like. Okay, some standard format of it. So this first graph is about the linear function. Okay, so y is equal to f of x is equal to x, so it's a straight line passing through the origin. Another one is for the quadratic function, f of x is equal to x square, it's like a parabola. This one is the absolute value function. Okay, it goes something like this. Now one thing I want you to remember is that when you are plotting it, even though for quadratic function you get the points like this, do not make a straight line. Okay, it's always a curve. Then this one is for the absolute function, and this one is for the reciprocal function. It goes something like this. And the last one I want you to remember is for the square root function. Okay, it goes something like this. So these are the standard format. I'm also going to put a picture of these so that you can take a screenshot. Now let's talk about vertical translation. Okay, so I have picked different functions for different transformations so that we can go through all of them. So this function is y is equal to f of x is equal to x square. It means that I'm talking about the quadratic function. Now I'm just going to plot these using different values. So for x, I have picked up -2, -1, 0, 1 and 2, and the corresponding values for y is equal to, so when I put x is equal to -2, I get 4. When I put x is equal to -1, I get 1, and similarly I get this data. Okay, so I have just plotted this particular function. Just focus on what I'm telling you right now, this function. So I have plotted all the points and the functions look something like this. This is the parent function. There is no transformation here. Okay, now I'm going to apply some transformation. So we are talking about vertical translation, means the value of c. Okay, something that has to do with y-axis. So the first transformation I'm going to apply is y is equal to x square plus c, which is x square plus 2. Now I hope you recall that a plus c value means that the graph is moving c units upwards. Okay, so let's see what my y values will be for the same x values. So this is -2 square, which is 4, plus 2, 6, -1 square, which is 1, plus 2, 3, and so on and so forth. I get these values. So let me just go ahead and graph these values. Okay, so the graph looks like this. I hope you can see that initially our graph, its vertex was touching, vertices what was touching the origin. Now it is at 0, 2. Okay, so you can see that x square plus 2 means that the graph has moved 2 units upwards. Similarly, you can put the values and find out the values for y is equal to x square minus 2. And if we plot that as well, we can see that the graph has moved 2 units downwards. Why? Because it is x square minus 2. Okay, so this is what a parent graph looks like. This denotes vertical translation, 2 units up, 2 units down. Okay, so that's about vertical translation. It deals with the c value. If it is plus c, it's moving upwards c units. If it is negative c, it's moving downwards 2 units. Okay, so that's vertical translation. Now let's talk about horizontal translation. Okay, horizontal has something to do with inside the bracket. So here I am picking the linear function. Y is equal to fx is equal to x. Okay, I'm picking the x values, the standard values, -2, -1, 0, 1 and 2. The corresponding values are going to be the same because y is equal to x, and I'm plotting this graph. So this is my parent graph. Okay, a line that is passing through the origin. Now let's apply the transformations. Okay, so y is equal to f of x plus 2. I want you to understand that this plus 2 is inside the bracket. Okay, so whatever value I'm getting here, I'm just adding plus 2. So -2 plus 2, 0, -1 plus 2, 1, 0 plus 2, 2, so on and so forth. So these are my values for these corresponding x values. Let's just try to graph that as well. So this is what the graph looks like. Okay, if I plot these values, now you can clearly see from the parent graph that the graph has shifted 2 units left hand side. Okay, so this shows that y is equal to f of x plus 2 means that the graph has moved 2 units to the left hand side horizontally. Okay, so this plus 2 means it's moving left hand side. Similarly, we can find out the values for x minus 2. So these are the values that I get, and if I plot the graph for that as well, this is what my graph looks like. Okay, so if you can just look at the parent graph, and here y is equal to f of x minus 2, it means that my graph has moved 2 units to the right hand side. So here was the origin and it is moving 2 units to the right hand side. Okay, so I hope this funda is clear. This is what a parent graph looks like. This is horizontal translation, 2 units to the left. This is horizontal translation, 2 units to the right. Okay, and remember, whatever it looks like, it's working right opposite of that. So plus 2 means to the left, minus 2 means to the right. So now we will look into vertical stretch and compression. Okay, so here I am picking the square root function. Y is equal to fx is equal to root x. Let's pick some values. So for 0 I get 0, for 1 I get 1, for 4 I get 2, for 9 I get 3. I have picked up the values which can be more convenient. Okay, so let's just graph this parent graph. It looks something like this. Okay, now I'm going to apply the transformations. So I'm multiplying the function with a value of 3. Now I want you to remember that this 3 is greater than 1. Now when you are multiplying outside the function, it means that it has something to do with the y-axis, y-axis, that's why vertical. So y is equal to 3 root x, and the values that I get are 0, 3, 6 and 9. Now I'm going to plot them as well. So look at this second graph here. So I want you to understand that whenever you are comparing the graph, always try to compare with the same values, with the same points. Okay, you cannot compare this point, the second point, with this third point. Okay, always try to make sure that if you are comparing the second point, only compare it with the second point. Only then you will be able to gauge the actual transformation. So from the second graph, if you can see that the third point is here. Look at the vertical distance from the x-axis and look at this third point here after applying the transformation. So the vertical distance from x-axis in the second graph is too much more than the vertical distance into the first parent graph. Okay, it means that my y value, my y-axis, its value has been stretched. Okay, it has been stretched. If you can just look at the difference. Okay, it was this much and now it is this much. It means that the graph has been stretched. Okay, that's why it is vertical stretch. And now if we look at this particular column, which is y is equal to 1 by 3 root x. Now this 1 by 3, why have I picked up this value? Because it is less than 1. Okay, so we are going to discuss both the values for greater than 1, for less than 1. For greater than 1, we already saw that we get a stretch in the graph. Now for less than 1, if we just plot those values, we get this corresponding graph. Okay, now let's just try to compare all three of them. Okay, this is the parent graph. This is the vertical stretch by a factor of 3. 3 is greater than 1, that's why I stretch. And this is vertical compression by a factor of 1 by 3. 1 by 3 is less than 1, that's why compression. Okay, so let's just keep in mind this third point. So now this third point is at this particular position in the parent graph. Look at it getting stretched. Okay, when we are multiplying by a factor which is greater than 1, and look at it getting compressed. Okay, from here to here. So this depicts the compression. Now after vertical stretch and compression, we are going to discuss about horizontal stretch and compression. Now this is exactly opposite of what we just discussed into vertical stretch and compression. Okay, so here we are taking the value of absolute x. Okay, so y is equal to fx is equal to absolute x. I have picked up different values, -2, -1, 0, 1 and 2, corresponding values for y is equal to mod x, absolute value of x. Now this is what the parent graph looks like. Okay, if you plot these values, you are going to get a graph like this. Now I am applying the transformations. So y is equal to absolute value of 2x. Now I am multiplying this function with a number 2. Now 2 is greater than 1. Remember, in vertical stretch and compression, when the factor was greater than 1, we used to have a stretch. Okay, so it is very understandable that in horizontal it's going to happen the opposite. If it were to stretch, here it's going to compress. Okay, so if we just plot these values and get the corresponding values and we plot the graph, it looks something like this. Now look at the first graph, look at the second graph. First is the parent graph, second is the graph after the transformation. Okay, can you see the horizontal distance? Look at this distance, look at this distance. Okay, can you see it being compressed? Okay, and similarly I am taking another factor which is less than 1 and I am getting the corresponding values and I am applying them into a graph. Now let's just try to compare the three of them. Okay, this is the parent graph, this is the horizontal compression for a number which is greater than 1, and this is a horizontal stretch. Okay, you can clearly see the compression and the stretch factor, right? So that's about the horizontal stretch and compression. It's exactly opposite of what we used to do in vertical stretch and compression. And the last one, which is reflection over the axis. Okay, so here I am picking the square root function, so y is equal to fx is equal to square root. Okay, let's pick some values for x. Now it is a square root function, so I'm just picking up the convenient values, 0, 1, 4 and 9 corresponding values. We all know how a parent graph looks like. Now let's take a negative sign outside the function. Okay, so the whole function itself becomes a negative, so all these values become negative. Okay, now I'm going to plot this. So if I plot them, I get a graph something like this. This is what a parent graph looked like, this is what a transformation graph looks like. And if you can just see, then I have literally just reflected this graph over the x-axis, and that's how I get this. Okay, so when the function is negative, then it means that reflection is over the x-axis. So when the negative sign is outside of the function, it means that this y value becomes a negative, right? When you put this negative here, it means y is equal to negative fx. It means that y got negative. In which quadrant does y become negative? Okay, so in third and fourth, and that's why in order to get y negative, you have to reflect over the x-axis. Okay, if that explanation helps. And another one is when you are putting the negative sign inside of the function. Okay, now we cannot take square root of a negative number, that's why we are going to pick new x values which are negative. Okay, so that we can get a positive inside. So 0, negative 1, negative 4, negative 9, this is the corresponding result. Let's try to plot that as well, and this is what we get. Okay, so here the reflection is over the y-axis. Why so? Because we need a negative x values. This x is negative. Where do you get a negative x value? When you flip the graph over the y-axis. Okay, so that's what happens, that when a parent graph is given and the function itself is a negative, then it gets reflected over the x-axis. Why so? Because we need y of negative values. And when the negative sign is inside of the function, literally opposite of what we just did. So if here we are reflecting over x-axis, here we are reflecting over y-axis. Okay, so I hope that this video was helpful to you and it cleared many of your doubts.